Matter can be clarified in a number of ways. Ancient Indian philosophers said that all the matter, living or non-living, was made up of 5 basic elements: air, earth, fire, sky and water. Modern-day scientists classify matter in 2 ways, on the basis of its physical properties and on the basis of its chemical properties. On the basis of physical properties, matter is classified as solids, liquids and gases. And on the basis of chemical properties, matter is classified as elements, compounds and mixtures. In this chapter, we will study the classification of matter on the basis of its physical properties. Physical nature of matter. Matter is made of particles. Everything around us is made of tiny pieces or particles. The number of particles in everything is, however, very, very large. The particles which make up matter are so small that we cannot see them even with a high-power microscope. Even without seeing them, we have certain evidence which tells us that all the tin is made of tiny particles. We will now discuss the case of sugar dissolving in water. When sugar is added to water and stirred, it dissolves quickly. The sugar seems to disappear. What happens to the sugar when it dissolves? Where does the sugar go? We can explain how the sugar dissolves and disappears in water by using the idea of particles. Both sugar and water are made up of very small particles. These particles are too small to see even under a microscope. When sugar dissolves, tiny sugar particles break off from each solid sugar granule. These sugar particles go into the spaces between the particles of water, and mix with them. So, the sugar solution will taste sweet even though we cannot see the sugar in it. How small are these particles of matter? Very, very small size of the particles of matter can be shown by performing the following experiment by using potassium permanganate and water. Potassium permanganate is a kind of matter. We take 2 or 3 small crystals of potassium permanganate and dissolve it in 100 milliliters of water in a beaker. We will get a deep purple-colored solution of potassium permanganate in water. Take 10 ml of deep purple solution of potassium permanganate from the first beaker and mix it with 90 ml of water present in second beaker, to dilute it. Due to this dilution, the color of potassium permanganate solution in the second beaker becomes a bit lighter. Now, take 10 milliliters of potassium permanganate solution from the second beaker and mix it with 90 ml of water present in the third beaker, to dilute it further. The color of solution will become still lighter. We keep on diluting the potassium permanganate solution like this a number of times. In this way, we get a very dilute solution of potassium permanganate in water, but the water is still colored. This experiment shows that just 2 or 3 tiny crystals of potassium permanganate can impart color to a large volume of water. From this observation we conclude that each potassium permanganate crystal must be made up of millions of small particles which keep on spreading and imparting color to more and more of water, on dilution. Since each tiny crystal of potassium permanganate is supposed to be made up of millions of particles, therefore, these particles must be very, very small. Characteristics of particles of matter. The spaces between the particles of matter can be shown by performing the following experiment by using water and sugar. We take about 100 ml of water in a beaker. Mark the level of water in the beaker with a marking pen. Also take 50 grams of sugar. Now add 50 grams of sugar in water in the beaker. Dissolve the sugar by stirring it with a glass rod. When all the sugar has dissolved, we get a sugar solution. Let us look at the level of sugar solution in the beaker. we will find that the level of sugar solution in the beaker is at the same mark where water level was initially in the beaker. This means that even after dissolving 50 grams of sugar in 100 ml of water, the volume has not increased. This can be explained by assuming that the particles of water have some spaces between them. When sugar is dissolved in water, its crystals separate into very fine particles. These particles of sugar go into the spaces between the various particles of water, due to which there is no change in the volume of water on dissolving sugar in it. The fact that there is no change in volume on dissolving sugar in water tells us that there are spaces between the particles of water. And these spaces accommodate the sugar particles. This also gives us another conclusion, that the particles, or molecules, in water are not tightly packed, they are somewhat loose, having spaces between them. Particles of matter are continuously moving. The best evidence that particles of matter are constantly moving comes from the studies of diffusion and Brownian motion. We will now describe the diffusion of copper sulfate into water. Copper sulfate crystals are blue in color. When a few crystals of copper sulfate are placed at the bottom of a beaker, or a gas jar, containing water, then water in the whole beaker turns blue slowly. This can be explained on the basis of motion of copper sulfate particles and water particles as follows. The crystals of copper sulfate dissolve in a little of water around them to form fine particles of copper sulfate in solution. Now, the particles of copper sulfate in solution are in motion and the particles of clear water are also moving. Due to the motion of their particles, the blue copper sulfate particles in solution move upwards in the beaker and the colorless water particles move downwards, and mix with each other. This is called diffusion. This diffusion of copper sulfate particles and water particles into each other goes on until the whole water turns blue. Thus, the spreading of blue color of copper sulfate crystals in water is due to the movement of both copper sulfate particles as well as water particles. Particles of matter attract each other. There are some forces of attraction between the particles of matter which bind them together. The force of attraction between the particles of the same substance is known as cohesion. The force of attraction or cohesion is different in the particles of different kinds of matter. This will become more clear from the following examples. If we take a piece of chalk, a cube of ice and an iron nail, and beat them with a hammer, we will find that it is very easy to break the piece of chalk into smaller particles. It requires more force to break a cube of ice, whereas the iron nail does not break at all even with a large force. This shows that the force of attraction between the particles of chalk is quite weak. The force of attraction between the particles of ice is a bit stronger, whereas the force of attraction between the particles of iron nail is very. States of matter. On the basis of physical states, all the matter can be classified into three groups: solids, liquids and gases. For example, 1 sugar, sand, iron, wood, rocks, minerals and ice are solids. 2 water, milk, oil, kerosene, petrol and alcohol are liquids. 3 air, oxygen, hydrogen, carbon dioxide and steam are gases. Solids, liquids and gases are called the three states of matter. In other words, matter exists in three physical states: solid, liquid and gas. The solids, liquids and gaseous forms of matter have different properties. The characteristic properties of solids, liquids and gases are given below. These properties can be used to distinguish between the three states of matter: solid, liquid and gas. The solid state. 1 solids have a fixed shape and a fixed volume. 2 solids cannot be compressed much. 3 solids have high densities. They are heavy. 4 solids do not fill their container completely. 5 solids do not flow. The liquid state. The liquids have the following characteristic properties. 1. Liquids have a fixed volume but they have no fixed shape. Liquids take the shape of the vessel in which they are placed. 2. Like solids, liquids cannot be compressed much. 3. Liquids have moderate to high densities. They are usually less dense than solids. 4. Liquids do not fill their container completely. 5. Liquids generally flow easily. The gaseous state. Gases have the following characteristic properties. 1. Gases have neither a fixed shape nor a fixed volume. Gases acquire the shape and volume of the vessel in which they are kept. 2. Gases can be compressed easily into a small volume. 3. Gases have very low densities. They are very, very light. A gas is much lighter than the same volume of a solid or a liquid. 4. Gases fill their container completely. 5. Gases flow easily. Diffusion. The spreading out and mixing of a substance with another substance due to the motion of its particles is called diffusion. The diffusion of one substance into another substance goes on until a uniform mixture is formed. Diffusion is a property of matter which is based on the motion, or movements, of its particles. Diffusion occurs in gases, liquids and solids. Diffusion is fastest in gases and slowest in solids. The diffusion is fastest in gases because the particles in gases move very rapidly. The diffusion is slowest in solids because the particles in solids do not move much. The diffusion in liquids is, however, much faster than that in solids. The rate of diffusion increases on increasing the temperature of the diffusing substance, by heating. This is because when the temperature of a substance is increased by heating, its particles gain kinetic energy and move more rapidly. And this increase in the speed of the particles of a substance increases. Can matter change its state? By increasing the temperature, by heating, a solid can be converted into liquid state, and the liquid can be converted into gaseous state, or vapor state. And by decreasing the temperature, by cooling, a gas can be converted into liquid state, and a liquid can be converted into solid state. Solid to liquid change, melting. If we heat ice, it changes into water. In this case, solid ice changes into liquid water, so a change of state has taken place. The process in which a solid substance changes into a liquid on heating is called melting, or fusion. So, when ice changes into water on heating, it is called melting of ice, or fusion of ice. A change of state takes place during melting, or fusion. The melting of a solid substance takes place at a fixed temperature. The temperature at which a solid substance melts and changes into a liquid at atmospheric pressure is called melting point of the substance. When a solid is heated sufficiently, it changes its physical state and becomes a liquid. This happens as follows. When a solid substance is heated, the heat energy makes its particles vibrate more vigorously. At the melting point, the particles of a solid have sufficient kinetic energy to overcome the strong forces of attraction holding them in fixed positions and break to form small groups of particles. And the solid melts to form a liquid. Liquid to gas change, boiling, or vaporization. Water normally exists in the liquid state. If we go on heating water, it ultimately starts boiling and changes rapidly into a gas called steam. In this case, the liquid water changes into a gas, so a change of state has taken place. The process in which a liquid substance changes into a gas rapidly on heating is called boiling. So, When water changes into steam rapidly on heating, it is called boiling of water. A change of state takes place during boiling. The boiling of a liquid takes place at a fixed temperature. The temperature at which a liquid boils and changes rapidly into a gas at atmospheric pressure is called boiling point of the liquid. For example, when water is heated to a temperature of 100 degrees Celsius, it boils rapidly to form a gas called steam, so the boiling point of water is 100 degrees Celsius. At boiling point, water changes its state from liquid to gas. The boiling point of a liquid is a measure of the force of attraction between its particles. Higher the boiling point of a liquid, greater will be the force of attraction between its particles. When a liquid is heated, the heat energy makes its particles move even faster. At the boiling point, the particles of a liquid have sufficient kinetic energy to overcome the forces of attraction holding them together and separate into individual particles. And the liquid boils to form a gas. If we cool steam, or water vapor, by lowering its temperature, it is converted into liquid water. In this case, a gas, steam, changes into a liquid, so a change of state has taken place. The process of changing a gas, or vapor, to a liquid by cooling, is called condensation. So, when steam, or water vapor, changes into water on cooling, it is called condensation of steam, or condensation of water vapor. A change of state, gas to liquid, takes place during condensation. The common unit of temperature and SI unit of temperature. We use Celsius scale of temperature for measuring temperatures in our everyday life. So, the common unit of measuring temperatures, like melting points, boiling points, etc., is degrees Celsius. The melting point of ice on Celsius scale of temperature is 0 degrees C, 0 degrees Celsius. And the boiling point of water on Celsius scale is 100 degrees Celsius. There is another scale of temperature called Kelvin scale of temperature, which is used by the scientists mainly for research work. The SI unit of measuring temperature is Kelvin, which is denoted by the symbol K. The melting point of ice on Kelvin scale is 273 K. And the boiling point of water on Kelvin scale is 373 K. The relation between Kelvin scale and Celsius scale of temperature can be written as temperature on Kelvin scale is equal to temperature on Celsius scale plus 273. Latent heat. The heat energy which has to be supplied to change the state of a substance is called its latent heat. Latent heat does not raise, or increase, the temperature. But latent heat has always to be supplied to change the state of a substance. The latent heat which we supply is used up in overcoming the forces of attraction between the particles of a substance during the change of state. The latent heat does not increase the kinetic energy of the particles of the substance. And since there is no increase in the kinetic energy of the particles, the temperature of a substance does not rise during the change of state. Latent heat is of two types. 1. Latent heat of fusion. 2. Latent heat of vaporization. The heat required to convert a solid into the liquid state is called latent heat of fusion, or latent heat of melting. And the heat required to convert a liquid into the vapor state, or gas, is called latent heat of vaporization. Sublimation. The changing of a solid directly into vapors on heating, and of vapors into solid on cooling, is known as sublimation. Effect of change of pressure. The physical state of matter can also be changed by changing the pressure. In other words, the physical state of matter can also be changed by increasing the pressure or decreasing the pressure. For example, gases can be changed into liquids by increasing the pressure, accompanied by lowering of temperature. And some solids, like solid carbon dioxide, can change into gases on decreasing the pressure. Evaporation. When a liquid is left exposed to air, its volume decreases gradually. This is due to evaporation. In this process, some of the liquid at the surface turns into vapor, or gas, and mixes with the gases in the air. Thus, when a liquid turns into vapor, or gas, it is said to evaporate. The process of a liquid changing into vapor, or gas, even below its boiling point is called evaporation. Evaporation of a liquid can take place even at room temperature, though it is faster at higher temperatures. Whatever be the temperature at which evaporation takes place, the latent heat of vaporization must be supplied whenever a liquid changes into vapor, or gas. The wet clothes dry due to evaporation of water present in them. And rainwater puddles also dry up because of evaporation of water. Common salt is also recovered from seawater by the process of evaporation. Some particles in a liquid always have more kinetic energy than the others. So, even when a liquid is well below its boiling point, some of its particles have enough energy to break the forces of attraction between the particles and escape from the surface of the liquid in the form of vapor. Thus, the fast-moving particles of a liquid are constantly escaping from the liquid to form vapor. Factors affecting evaporation. The evaporation of a liquid depends mainly on the following factors. 1. Temperature. 2. Surface area. 3. Humidity. 4. Wind speed.